Hi, so this video is on systems of linear equations, the introduction. Systems of linear equations are something that I really like. It's probably my favorite topic in Algebra 1. It's really the first time I think that you get to see in Algebra 1 how what you're learning gets used outside of just, okay, let's learn something. Here's 20 problems, just do them, right? We see a little bit of that when we work out the word problems for linear equations. You get data and you have to make a graph from it and something like that, write an equation maybe. But the first time you really get to see how to apply that is in this particular chapter, unit, whatever you want to call it, on systems of linear equations. So what are they? Well, a system of linear equations, we'll write out the definition. A system of linear equations is quite simply a group of equations. That's the definition. We have to have two or more equations. And you can have systems that are not linear. So you could have a system with quadratics, so that's two parabolas, or two other polynomials, or whatever. But for right now, we're just going to focus on linear. Two or more equations that may, keyword being may, have one solution, no solutions, or infinite solutions. So what we have here is we're going to take two equations. So y equals 3x plus 1 and y equals 1 half x plus 5. Let's just say, for example. That's a system. And that system, we say, has one answer to it, more than one answer, infinite solutions, or no answer at all. And the way that that works, what's the point? What are we doing? It's a way to solve an equation with its partner or partners that have more than one variable, right? If I said y equals 3x plus 1 and I said solve for x, well, you can't find a value for x because there's a number of different ones, right? Any x that goes with a y that satisfies that equation is a solution, right? We've seen that before. So if we want a definite single value for x and y, we need to give it a partner, which is why we always have at least two. The solution I mentioned is the ordered pair. And for this, we would be saying x comma y, that the math language is satisfies all equations. Basically, in other words, it makes all equations true. It works. Okay, it's an x and a y, and if you put them into each of the equations, then you're going to find a true statement. 4 equals 4, 5 equals 5, 0 equals 0. Okay. We have some terms for this. So if we have a system with exactly one solution, one x and y that works in, we'll say, both equations, we call that consistent and independent. So consistent means that there is a solution and that they are independently, each of the lines, independently arriving at that solution point. If it is infinite, that means that the lines are the same. They share all values of x and y. Anything would work. So in that case, you say it's consistent because there's a solution. But it is dependent because they're the same. They're together. They only do things together because they're the same thing, like identical twins. Not that identical twins do the same thing all the time together, but you get the comparison. And then lastly, there is no solution. What if no x and y will work in both equations? Well, then we just say it's inconsistent. There is no solution. So what does it mean to be a solution? I said that it is a value, x and y, that works in all of the equations you are given. And I want to point something out about this system, and that's going to cut down on some of our answer choices. There are multiple ways that I can give you a system. The most common way is I will give you two equations, and or your teacher, if you're just watching this video on YouTube, might never even meet me. But whoever can give you two equations in some format, slope-intercept form, point-slope form, some random in-between collection, of terms. And you figure it out. You do some algebra, maybe you graph them, and we'll talk about each of those in other videos. And then you find your solution. Another way that I could give you a system is like the one I've given you here. Y equals 1 and y equals 2x minus 1. It is perfectly acceptable and perfectly correct for me to give you one of your variables. I have just told you in this example that y, the value of y in my solution to this system, if there is one, is 1. Okay. So that means my ordered pair, I already know the y coordinate. It's 1. So that means C is not the answer, and neither is D. Those both have x equal 1. So the answer is either A or B. First of all, the other thing, before we actually figure out which one of those two it is, if you have a situation where you have found or have been given x or y, so I've told you x is whatever, y is 1, that means that system is independent. That means that system has a solution. If it didn't have a solution, you wouldn't be able to find one of the variables. If you find one, you're going to find the second one. And you're never going to find one and not the other. Okay? The other thing is if you have a y equals 1, a value, it's not going to be infinite solutions, okay? The only way for them to be infinite solutions, I kind of mentioned this, is to be the exact same equation. Well, these two are not that, okay? Infinite solutions is probably the easiest one to recognize. Okay, so how do I identify a solution? Well, what do I would do guess and check. This is the one time in algebra that guess and check is acceptable and, in fact, encouraged. So let's take option A. We know that y is 1, so we don't need to deal with the first equation. But we need to go with the second one. So I'm going to check what happens if I plug in that ordered pair for x and y. So in this situation, we have been given y is 1 and x is 3. And I'm going to check, just as I would in any regular equation, does that ordered pair work? And it does not. 1 is definitely not equal to 5. So A is not the answer. Now, I think B is the answer, but I do need to check it. It is possible that they've just not given me the correct answer out of these choices. So I'm going to put 1 in for x and 1 in for y, because the point is 1, 1. 1 equals 2 minus 1, 1 equals 1. That is correct. So the solution to this system is 1, 1. And that is the only solution. You can't have 2, you can't have 3. It's either 1, infinite, or none. And like I said, because we were given y equals 1 to start with, we know it's got to be one solution. Because infinite, they would be the exact same equation, and no solution, I wouldn't be able to even have found y equals 1. All right, let's take a look at one more. Y equals 1 half x plus 3, and y equals 5 half x minus 1. First of all, this is not infinite solutions. These are definitely not the same equation. Now, I don't know which one it is. I don't have any clues like last time. So I just have to start from the beginning. So let's start with option A. Now the nice thing is, if I find one of these is a solution, then I get to stop, because there can be only one solution. And I'll tell you it's not no solution. We'll talk about why in another video. So, whoops, that would be negative 4 for y, 2 for x. Negative 4 equals 1/2 of 2 is 1 plus 3. Well, that gets me negative 4 equals 4. That is definitely not correct. A is not the answer. Okay, well, let's try B. And I don't need to check if I am doing it this way, if I am identifying a solution by guess and check. And again, that's perfectly fine here. That's what they're encouraging me to do by giving me these choices. If I find that one equation, that the ordered pair doesn't work, I don't need to bother with the other one because it has to work for both. So this one would be negative 4 equals 1/2 of negative 2 is negative 1 plus 3. That would give me negative 4 equals positive 2. That's still not right. B is not the answer. Okay, let's try C. So same thing again. And like I said, I think that 1/2 is easier to work with than 5/2, so that's why I'm testing it with that one first. 4 and 2. 4 equals 1/2 of 2 is 1 plus 3. 4 equals 4. Okay, I found a winner, sort of. It works in the first equation. But if it is the solution to this system, it has to work in the second equation. So I'm going to set it up again. 5/2 x minus 1. And 4 is y. And 2 is x. 4 equals... So 5 over 2, that's going to be 5 minus 1. Oops, I'm writing the answer. 4 equals 4 again. And there you have it. C is the solution. And because C worked in both equations, we don't need to test out answer D, because it's not going to be it, because there's only one solution. All right, thanks for watching this introduction. Be sure to check out the videos on the 3 methods of solving systems: substitution, elimination, and graphing. I suggest you start with the graphing because that's how most algebra textbooks will start.